Hello, everybody. My name is Gianluca Mardente. I'm a principal engineer at Cisco Systems. And today I will be presenting Sveltos and specifically how Sveltos can help platform admin to onboard tenant admins and allow each tenant admin to deploy add-ons and applications in a subset of managed Kubernetes clusters. We all know that Kubernetes by itself is not a complete solution, that when you build that, to build a production clusters, you have to deploy add-ons and applications. And if you're managing a fleet of Kubernetes cluster, managing add-ons and applications is not a trivial problem. So Sveltos wants to help there. And the idea behind Sveltos is simple. Sveltos runs in a management cluster. And from the management cluster, a fleet of managed Kubernetes clusters can be accessed. And Sveltos can be easily told what to do. Essentially, select a set of managed Kubernetes clusters using a Kubernetes selector and list the add-ons or application that needs to be deployed. And Sveltos will take care of the rest. So we have a management cluster where Sveltos is running, and we have a bunch of managed Kubernetes clusters. Sveltos has built-in support for cluster API, meaning that every cluster which is powered by cluster API is automatically discovered by Sveltos. But any other cluster which can be easily registered to be managed by Sveltos. For instance, in this case, we have GK cluster or Sivo clusters or Rancher cluster or Redsler cluster, which are all registered with Sveltos. And at this point, pretty much Sveltos can manage add-ons and application from the management cluster on to these managed clusters. The only requirement of Sveltos is that there is a network connectivity between the management cluster and each one of those managed clusters here. Cluster profile is the main CRD that is used to instruct Sveltos what to do. And it has, in the spec section, like 4 main fields. The first field is the cluster selector. The cluster selector is just a pure Kubernetes label selector. And it selects a subset of managed Kubernetes cluster. In this case, it's selecting all the clusters which have the label environment set to FE, stands for functional verification. So first thing is select a set of clusters and then tell Sveltos what to do. In this case, what we're telling Sveltos, we have an Helm charts section where we can list one or more Helm charts. In this case, we're asking Sveltos to deploy Caverno version 2.6.0 in every cluster that it's matching the cluster selector env equals FE. And there is a customization def where you can say, you can list all your sources where you have customization file. In this case, pretty much you have a Git repo containing customization files in the path hello world. And what Sveltos will do, we'll take all those files, we'll run the customization SDK, and then we'll deploy the output in the ENG namespace in every cluster matching the cluster selector. And finally, there is a policy ref section where you can reference one or more config maps and or secrets. And the config map and secrets can contain one or more Kubernetes resources. In this case, I have an example where there is a config map, which is in the default namespace called contour gateway, which contains a gateway class, a namespace, and a gateway. So if there is a cluster profile referencing this config map, in every cluster matching the cluster profile, Sveltos will take the content of this config map, so the gateway class, the namespace, and gateway, and will deploy those resources in every cluster matching the cluster profile. And you can put in the config map both YAML or JSON. This is essentially a summary of how Sveltos works. We have a management cluster where Sveltos is running, and we have 2 clusters which are powered using cluster API. So we apply in the management cluster a cluster profile that says select every cluster matching the labels environment prod, stands for production, and deploy Caverno version 2.5.0 in every such cluster. So if we add the label environment production on the first workflow cluster, sveltos will detect that this workflow cluster is a match for this cluster profile, and will take all the listed add-ons and applications and deploy those one. In this case, we only have Caverno, so sveltos will deploy Caverno in this workflow cluster. Likewise, if we add the label environment production on the second cluster, sveltos will run the same logic. Will react by detecting that this cluster is now a match for this cluster profile, and it will deploy Caverno in this cluster as well. What differentiates sveltos from all the other tools which are available today to manage add-ons and applications in a fleet of Kubernetes clusters? Well, sveltos allows you to express Helm charts and raw YAML and JSON as template, and instantiate those templates using information which is present in management, in resources which are present in the management cluster. For instance, in this case, we are asking sveltos to deploy Calico in every cluster, in every production cluster, but the value section of this Helm chart is expressed as a template. And it's referring the cluster. So what sveltos will do before, we'll find every cluster matching this cluster selector. And for every cluster, we'll take the cluster instance, which is present in the management cluster and represents the cluster where sveltos is about to deploy this Calico. And we'll take the spec cluster network pod cyber block section of this resource, which again is present in the management cluster. We'll instantiate this value, this template, using the information found in the resource present in the management cluster. And after this instantiation, we'll go ahead and deploy the resources. By default, sveltos has access to a set of resources that represents the cluster. If you're familiar with cluster API, the cluster API cluster instance representing the cluster, the infrastructure provider, the kubeadm control plane, or the sveltos cluster instance, which represents a cluster, which a GK cluster, for instance, which has been registered to be managed by sveltos. But sveltos can be instructed to fetch any resource present in the management cluster and use its content to instantiate those templates. In this case, for instance, sveltos is being instructed to fetch a secret which is present in the management cluster, which is in the default namespace and called .scalar, and instantiate the content of the configmap, which expresses a template using information which is present in the secret key. You just have to give like sveltos the right permission to fetch those type of resources if you need like extra resources. But sveltos has the capability at the point like to fetch hunting. Now, what if we are a platform admin and we want to onboard a bunch of tenants? One approach is to give every tenant a subset of clusters. So what you can do in this case is that as a platform admin, you can create cluster profile in the management cluster. Those cluster profile can match any cluster in any namespace. Then you can onboard a tenant by giving every tenant his own namespace. And sveltos has another CRD, which is called profile. The profile is exactly the same as a cluster profile. It has a cluster selector, where you can select like clusters where to deploy the add-ons and applications. And then it has an Helm chart section, a customization of sections, and a policy of sections. The only difference between a cluster profile and a cluster, that a cluster profile is cluster-wide, so it can manage any cluster in any namespace. A profile is a namespace resources, so I can only match clusters which are in the same namespace where the profile is defined. So what happens in this case is that, again, you are the platform admin, and the platform admin can create cluster profiles, and the add-ons and applications listed in those cluster profiles can be deployed like in any cluster, in any managed cluster, because a cluster profile can match any cluster in any namespace. But then you onboard tenants by giving every tenant his own namespace. So in this case, the tenant 1 has been given like the tenant 1 namespace. The tenant 2 has been given the tenant 2 namespace. So the tenant 1 at this point can put like his own profile configuration, And this on profile configuration is only going to be deployed on cluster which are defined in the same namespace. In this case, the clusters which manage cluster with the blue background. The tenant2 namespace can put, the tenant2 admin can put his own configuration, and it's going to create like his own profile configuration in the namespace that has been assigned to tenant2. And this profile configuration put by the tenant2 admin is only going to affect clusters which are in the same namespace. In this case, the managed cluster with the yellow background. So what happens is that every tenant can put his own configuration listing which add-ons and application needs to be deployed, but two tenants do not interfere with each other. The configuration set by tenant is only going to be deployed in clusters which have been assigned by the platform admin to the tenant. This is one way of doing it, and this works well when you want to give a cluster to a tenant. So but another scenario is what happens if instead I have a set of clusters and I want to give one of these clusters to be shared across multiple tenants. Well, Sveltos is a solution for that as well. So what Sveltos introduced in this case is yet another CRD. It's the role request CRD. And the role request CRD, it's a cluster-wide resource. And it contains a cluster selector, which select a set of managed clusters. And then it has a role rep section, which reference one or more config maps. And in the reference config map for secrets, you can put a bunch of cluster role and role. And then you have an admin section. The admin section identifies an admin. In this case, I'm saying that the engineering admin as in every cluster matching the cluster selector department equals engineering, as all the permissions that are defined in the config map in the default namespace called full access. Let's look at an example. Before we go there, how can Sveltos know that a cluster profile is being created by given admin? Well, Sveltos expects this following label to be present in every cluster profile. So if you want Sveltos to say to know that this cluster profile is being created by a given admin, add this label project sveltos.io admin name with the name of the admin. How you can achieve that? Well, if you're a platform admin, you can use an admission controller, and Sveltos, for instance, provides this Caverno cluster policy that says every time a cluster profile is created, take the name of the service account creating this cluster profile and add this label here. Now, let's see in an example how this works. As a platform admin, you can create a role request that says in every cluster matching the cluster selector environment pre-release, give the admin eng all the permissions that are defined in the config map in the default namespace called full access. And this config map contains a cluster role ****, which means that we are giving the engineer admin cluster admin permission in every cluster matching the cluster selector environment pre-release. So what happens if later on the tenant admin eng creates a cluster profile, and we can see that this cluster profile is being created by the tenant admin eng by the presence of this label, project sveltos.io admin name, that the Caverno is going to be deployed in the every cluster that is matching the label environment pre-release. Because we have given this admin, the previous slides, we gave this admin eng full permission in every cluster matching the label environment pre-release. But what happens if the same admin, so you see that the label is again project sveltos.io admin name eng, tries to deploy Caverno in every cluster matching the label environment production. Well, in this case, this admin here has not been given permission to deploy anything in this cluster, so Sveltos will block that. This concludes this presentation, and thank you for your time, and I hope this was useful. Thanks.